Try to remember exactly what you ate for dinner 2 nights ago. Now, what is 2 plus 2? Notice the difference? The math problem was an instantaneous reflex, but recalling the meal took a distinct moment of searching. Your brain organizes information by how quickly you need it, and a computer does the exact same thing. We often think of a computer's central processor as a conscious brain. It does the math and executes the logic. But a processor cannot actually think without an intricate memory system to hold its thoughts while it works. There is a constant trade-off in computing. You can have massive storage capacity, or you can have lightning-fast speed, but it is nearly impossible to get both in the same physical space. To solve this, a computer divides its memory into specialized tiers. By organizing data from the slowest, deepest archives up to the fastest active workspace, a machine can juggle dozens of complicated tasks at once without crashing. Let's start at the foundation with secondary memory, also known as storage. Think of this like your long-term memory of a childhood home. You rarely need to think about it, but the details are retained permanently. We call this type of memory non-volatile. That simply means the files, photos, and programs stay safely locked away, even when the computer's power is completely turned off and unplugged. Decades ago, massive physical reels of magnetic tape held this permanent data, reading and writing information onto long, winding strips of plastic. Modern hard disk drives still rely on physical movement. They store massive amounts of information by magnetizing specific locations along concentric rings on these densely stacked metal platters. Because secondary memory relies on mechanical parts, spinning and scanning to find files, it is incredibly slow for a processor to access directly. Long-term storage lags behind the speed of active thought. To run smoothly, the computer requires a much faster intermediary workspace to prepare information for the processor. This brings us to primary memory, specifically RAM, or random access memory. RAM is the computer's short-term working memory. It acts like a temporary workbench, holding only the specific programs you are actively using right now. To maintain rapid speeds, these green memory modules plug directly into the motherboard right next to the processor, minimizing the physical distance electronic signals have to travel. RAM thinks incredibly fast, but it is volatile. It suffers from digital amnesia. The exact second the power flickers or cuts out, RAM loses every single thought it was holding on its workbench. To prevent total chaos, the computer relies on a second type of primary memory called ROM, or read-only memory. ROM acts like a hardwired biological instinct. You don't need to consciously remember how to breathe, and a computer uses ROM to know exactly how to wake up when you press the power button. These vital survival instructions are permanently burned directly into the physical circuitry of microchips like this. They cannot easily be erased, ensuring the machine always remembers its basic functions. Between the quick workspace of RAM and the deep instincts of ROM, the processor has plenty of active thoughts, but it still needs a specialized delivery system to move all these signals back and forth. For the absolute most urgent instructions, there is cache memory. Think of it as a reflex, or having a word right on the tip of your tongue. It is a tiny, lightning-fast buffer built directly into the processor itself. Cache intercepts the most heavily repeated tasks, so the processor doesn't waste precious time making a slower trip out to the RAM workbench. So, how does a central processor manage to physically coordinate cache, RAM, and long-term storage all at the exact same time? This schematic illustrates the system bus, the computer's nervous system. It carries signals between the processor and memory tiers using 3 strict jobs. The address bus pinpoints the exact location. The control bus commands the read or write. Finally, the data bus carries the files. This continuous loop of finding an address, commanding an action, and retrieving the data is called the fetch, decode, execute cycle. It fires billions of times every single second, giving you just the illusion of one seamless, conscious machine. Think about the last time your computer stuttered and froze because you had 50 web browser tabs open at once. The machine wasn't out of permanent storage space. Instead, your short-term workspace, your RAM, simply ran out of room to hold active files. The computer was experiencing a digital brain fog. You can apply this directly to the hardware you buy. If you want to archive thousands of high-resolution family videos, you need to prioritize massive secondary memory, buying a larger hard drive or solid-state drive to act as your deep vault. But if you want to play intense video games or edit complex media projects, You need to prioritize expanding your short-term primary memory. Adding more RAM gives the computer a wider desk to handle complex active tasks without freezing. The humming circuits inside your devices are highly engineered, mechanical networks, but they operate by directly mirroring human biology. By learning how a device balances deep, permanent storage with quick, active reflexes, you understand exactly how a computer manages to think.